Hello everyone, my name is Nandini Shrivas and today we are diving into the absolute foundation of intelligent system, knowledge representation and reasoning. Now take a look at the screen. What you see is a knowledge graph, a simple map of relationships. Here you can see Da Vinci painted Mona Lisa and that Mona Lisa which is in Louvre, which is currently in Paris. Now this isn't just a data, it's knowledge, structured, contextualized and ready for a machine to reason with. The core question in AI is not how can a machine compute, but how can a machine know anything? Knowledge representation or KR is the answer. It's the method of structuring and storing knowledge so computer can process or reason with and also act upon it. Now, KR is the bedrock upon which intelligence AI systems are built upon. Now we will move on to the second slide. That's the core objective. What are the things we are going to learn in this whole podcast on knowledge representation? That is, define and differentiate it between knowledge representation, the challenges we face, the ethical risks, and also its application, its principles, and its ethics. Now, moving on to the next slide. We start with raw data, just facts and figures. When you process and organize the data, it becomes information. But when you structure that information with rules, patterns, and relationship, it becomes knowledge. Knowledge is what enables reasoning with decision making. Now, as we have known about knowledge, now let's know about what is first order logic. Now, first order logic, a formal system in AI using predicates, quantifiers, variables, and functions to represent objects in relationship. It supports deeper, more expressive reasoning. This is what first order logic is. This hierarchy culminates in intelligent action, the ability of an AI system to take informed, reasoned decisions. KR is the bridge that transforms raw data into this actionable knowledge. Our objective today is to define and differentiate this progression, compare the key knowledge representation paradigms, understand the core principles, and analyze the major field challenges. Now, let's know about inference techniques in first order logic. What are those? Once we have known about knowledge, we need to apply logic to derive new facts. This is inference. A crucial technique in symbolic AI is chaining. We have two primary methods for directional reasoning. The first is forward chaining, and the second one is backward chaining. Now, what is forward chaining? It is data driven. You start with known facts and apply rules to deduce all possible new conclusions. And what is backward chaining? It is goal driven. You start with specific goal, say a question, and work backward to find the minimum set and of facts needed to support it. This is ideal for query answering and logical proof system. In essence, knowledge representation provides the language and inference provide the logic to think. Now, moving to our next slide, that is what actually is knowledge representation as we learned about in first slide in the description of introduction. Let's know it once again. Knowledge representation is the method of structuring and storing knowledge so that the computer system can process, reason, and act upon it. As I told you earlier, it's a good knowledge representation system must meet four critical principles. Those are representational adequacy, inferential efficiency, and acquisitional efficiency. Balancing these often competing needs like expressiveness versus compatibility is the core task of knowledge engineer. For instance, a system that can represent a rich, complex world may be slow to reason with. Now, as we are knowing about knowledge representation, what are the essential characteristics of knowledge representation? Let's know about it. A good knowledge representation. should be expressive. That means it should have ability to represent rich, complex relationships. It should be computability. That means reasoning processes. It should reason process must be practical and it should be able to be implemented. It should be readable and maintainable, understandable for both humans and machine. It also should be scalable, modular, and reusable. Last but not the least, clarity and unambiguity, precision in meaning to avoid misinterpretation, so that very less misinterpretation occurs and there are very less faults. The main factor, paradigms, types of knowledge representation. Throughout AI history, several major paradigms have emerged, each with its strengths. First is logic-based system, which is propositional logic, first-order logic for formal reasoning. Semantic network, graph-based representation of concepts and their relations. Frames, structured object-like templates with slots for attributes and values. Advanced specialized knowledge representation, production rule, simple if condition, then action. Ontologies. Formal definition of domains concept like OWL or RDF, which are crucial for knowledge sharing and the semantic web. Procedural knowledge representation encodes how to knowledge through algorithm and procedures. Now, as we are learning about knowledge representation faces four critical challenges. And the first one is common sense knowledge. AI lacks the intuitive, implicit knowledge human use daily. Key issues include the frame problem, what changes, the qualification problem, accounting for all condition, and also the ramification problem, predicting all consequences is hard for AI. Solutions involve massive knowledge base like CYC or leveraging large language models, LLM. The second challenge that knowledge representation face is uncertainty and incompleteness. Real world data is noisy and unambiguous. We address this by probabilistic reasoning using Bayesian network, fuzzy logic, which allows for degree of truth, and non-monolithic reasoning that lets system retract conclusion when new evidence appears. The third challenge knowledge representation face is scalability and efficiency. The volume of data creates computational bottlenecks. We optimize with descriptive logic to balance expressivity with decidability and use specialized tools like graph databases, example Neo4j, or for efficient querying for complex graph. The fourth and last challenge that knowledge we face during knowledge representation, the symbol grounding problem. Purely symbolic systems are self-contained and unanchored. The definition only refer to other symbols. The solution is to ground symbols in direct experience. Just like humans do with perceptual and action grounding, techniques like embodied AI, multimodal learning, and vector embedding like BERT are working to build this richer, grounded understanding. Now, let's know about the features of modern knowledge representation. The first is neurosymbolic AI, combining the logical rigor of symbolic system with the robust learning of neural network. Explainable AI (XAI), focusing on causal reasoning to make AI decision transparent and understandable to humans. Automated knowledge acquisition, system that can automatically learn and integrate new knowledge, making KB self-updating. Now let's know about the impact of robust knowledge representation, which is already visible in the real world through virtual assistants, medical diagnosis system, autonomous robots, and semantic wave. Few examples are Siri, Alexa, and also there are other webs and all example in our real world. So this is how the knowledge representation evolution happened from logic to neurosymbolic AI. And for the conclusion, knowledge representation is the fundamental bridge. It is what transforms unstructured data into structured, actionable insights, enabling AI to understand and intelligently interact with the world. By mastering the core concepts, principle, and challenges we have discussed today, you will be able to equip to navigate the complexities of modern AI development. Thank you for your attention.